RSM-HGT host operation teaching video. 1. Device description. RSM-HGT host adopts 12.1-inch touchscreen. There are ultrasonic interface, sediment interface, USB interface, power adapter interface, power on-off interface on the side of the host. Main interface introduction. Time, electric quantity display, XX, YY 4 directions of waveform area, depth, set, sample, new, mode, adjust, auto, analyze, file, exit. Setting interface introduction. Basic PARM, hole info, direction, basic PARM, location diagram, instrument parameter, pulley parameter, OK. 2. Applications. The ultrasonic drilling monitor can be applied to hole quality testing of bored piles on railway, highway, port, high-rise building, and etc. Trenching quality testing of the groove of diaphragm wall. It can also be used to detect the thickness of sediment. 3. Operation preparation. 1. Power on. Select to enter ultrasonic mode. 2. Fill in the basic PARM. 3. Set instrument parameter. The initial parameters are default, which can be modified according to actual needs. 4. Set pulley parameter. When using auto double winch, the pulley parameters are pulley diameter 114, cable diameter 6. When using auto single winch or manual single winch, pulley parameters are pulley diameter 110, cable diameter 10. 5. After the setting is complete, save and exit to the main interface. 4. Data sampling and on-site analysis. 1. Data sampling. 1. Click Sample, make data prediction, and adjust the gain appropriately. 2. Click New to save the corresponding file name. Click Sample to start sampling. 2. On-site analysis. When the test is completed, click the Analysis button on the main interface to enter the Analysis interface. Or click File, select the file to be analyzed, and click Analyze to analyze the historical file. After entering the analysis mode, the host will automatically read the star.aqo file to generate an ultrasonic hole quality testing image. Step 1. Backcut. Click 1 Backcut to enter background denoising mode. Click it repeatedly to highlight the waveform of hole wall. Step 2. AI Trace. Click AI Trace to enter Auto Trace mode. The program will shield the buttons irrelevant to operation to prevent accidental touching by the operator. Select the continuous points. The points close to hole bottom are prioritized, with strong reflection on hole wall of image to complete the auto and intelligent trace of span. Step 3. Lock Trace. Click Lock Trace to enter local trace mode. Modify the area where the local tracking effect is not ideal. After the tracking is completed, click the Quick Trace button to exit AI Trace mode. Step 4. Man Trace. Click Man Trace to enter Manual Trace mode. Select the sections with poor effects of Auto Trace, draw the span manually, and click Quit Trace to complete manual trace of span. Step 5. Cut Noise. Click Cut Noise to control the near-field noise of mud, and control the near-field noise of mud in collected data. Generally, it is recommended to perform noise control for 2 to 3 times, so as to effectively control the near-field interference of mud and highlight the reflected echo signal of hole wall. Step 6. Cal Analy. Click Cal Analy to enter calculation and analysis of drilling quality. Firstly, select hole forming or groove detect based on the tested object. Then click Apply button to calculate the average aperture, maximum aperture, minimum aperture, eccentricity, and verticality based on the time of span, in order to conduct systematic evaluation of drilling quality scientifically. Adjust the speed of sound wave in mud properly based on the sound wave collected at site and its speed in mud, and then click Apply button to modify the value of hole diameter. The span can be provided with proper smoothing and translation to make the span smooth and fitted to the realities. 7. Save. Click Save to pop up the prompt window. The software will save the file and generate image report of drilling quality testing intelligently based on the user's behaviors. star.aqo is the raw data file format. star.aqd is the processed data file format, and the PDF document of the generated hole testing report can be selected in color or black and white version. While the file is being saved, the dialog box displays the saving progress, saving time, and path. 8. Data export. After field tests, export the data through the USB port. Insert the USB flash drive or mobile hard disk. Click File and then select Export to copy the saved data into the USB flash drive or mobile hard disk. 9. Click Exit button in the main operation window to quit the program automatically. 5. RSM-HGT Ultrasonic Drilling Analysis Software. 1. Main operation window. 1. Profile info includes the schematic diagram of profile number, point distance millimeter, and hole trench number, in which the two holes connected by red line indicate the profile that is being viewed. 2. Depth correction includes testing depth, depth correction, lifting error correction. 3. Waterfall wave, the main part of the main form, and can also choose the data sheet mode. 4. Time coordinate axis. 5. Depth coordinate axis. 6. Right curve graph. Display the whole wall curve. 7. Shortcut button at top. 2. File drop-down menus. 1. Open. 2. Open result file. 3. Save result file. 4. Print content setting. Set the output results. Select the printing curve graph, grayscale diagram, data sheet and parameters of all diagrams. 5. Print page setting. 6. Print setting. 7. Print preview. 8. Print. 9. Recent files. 10. Exit. 3. Setting drop-down menus. 1. Testing parameter. Display the set parameters during the field collection of read files. 2. Display setting. Set the display effects of waveform and grayscale in the current display interface of waterfall wave. 3. Standard. Currently, the program supports multiple standards. Once a proper standard is selected, all data and results will be calculated and outputted according to the selected standard. 4. View drop-down menus. Zoom in, out. Pull up and compress the display range of waterfall wave and grayscale. 3D display can draw the 3D hole diameter based on the current hole signals. 5. Waveform processing drop-down menus. 1. Filtering. Enter the high-pass and low-pass filtering parameter to perform digital filtering to the data of all files. 2. Enhance. Amplify the viewed waveform proportionally. 3. Acoustic time correction. Adjust the delay of all profiles. 4. Velocity correction. Recalculate the hole diameter based on the inputted mud wave velocity. 5. Partial normalization. Amplify some regional signals. 6. Exponential amplification. Amplify the signal. 7. Auto-amplify of gain. Process and identify signals by using the auto-gain algorithm. 8. Curve adjust. Adjust the display proportion relationship of the right curve graph. 9. Curve smoothing. Perform smoothing to the whole wall curve of current profile. 10. Amplitude line linked with acoustic timeline. When it is selected, it will judge the amplitude of first wave when clicking Reinterpretation of first wave time. 6. Analysis and export drop-down menus. 1. Export to Word. 2. Export to BMP. 3. Export to Excel. 4. Test result summary. 7. Display settings. 8. Waveform analysis. 1. Enter and modify the project name, test unit, tester, requester, supervision, hole trench number, hole trench depth, meters, hole diameter, millimeter, drill trench date and testing date. 2. Right-click the color grayscale to draw the well wall line manually. Hold the right key during setting. Draw it downwards to the hole bottom along with hole wall. To draw the hole wall curve of right side, click Cancel to cancel the well wall line. 3. If wave velocity entered during field test is incorrect, select Correct Sound Velocity in Waveform Processing menu on the main interface. 4. Multiple printing modes are available. You can even define the printed header. 9. Display and printing setting. 1. The style combination and line width of the printed curve can be selected in the curve graph. 2. The line width and grayscale clarity can be selected in the waterfall wave graph. If acoustic time curve is selected in waterfall wave graph, the position of first wave will be marked by the vertical line in the printed waterfall wave graph. 3. The datasheet printing cycle can be selected in the datasheet. If waterfall wave datasheet is selected, the waterfall wave appears at the left side and the corresponding datasheets appear at the right side. 4. Select the printing contents such as curve graph, waterfall wave graph, grayscale diagram, datasheet and waterfall wave datasheet at the upper side. 10. Output the corresponding report file. 6. RSM-HGT Analysis Software. Interface Introduction. 1. Basic Information Bar. You can fill in or complete the project information. 2. Parameter Information Bar. Drawing Display Scale. If the parameters entered in the field test are wrong, you can adjust the drawing scale appropriately. Personal Table Head. You can select the desired header content. Select to judge whether the thickness of the sediment is qualified. The thickness of the sediment is automatically generated from the position selected on the right graph. 3. Report Export Bar. Reports can be generated before and after the location of the sediment is determined. 4. Depth Resistivity Graph. There is a linkage relationship with the depth resistivity table on the right. Select the corresponding position and click the right mouse button to prompt to determine the sediment depth. 5. After determining the thickness of the sediment, click on the Print Preview or directly generate the report.